Before solving practice set 1.2, we will just go through the properties or a theorem which we learned earlier. The first theorem which we learned is BPT. In the triangle ABC, if DE is parallel to BC, if two lines are parallel, then the ratio of these two segments are equal. That means AD upon DB is equal to AE upon EC. It is by BPT. First theorem. Converse of this is, in this triangle PQR, if the ratio of PS to SQ and PT to TR is equal, then these two lines will be parallel. So if PS upon SQ is equal to PT upon TR, if this is given, the ratios are equal, then ST is parallel to QR. It is by converse of BPT. Second theorem. Third theorem is of angle bisector theorem. In a triangle ABC, BD is a bisector of angle ABC, then the ratio of these two segments to these two segments are equal. That means the bisector divide this segment into two segments, that is AD and DC. So ratio of these two, the remaining two sides AB and BC. So AB upon BC. Okay. So this is called the property of angle bisector theorem. Okay. And the fourth one is property of three parallel line and its transversal. Suppose L, M and N, all these three lines are parallel. Then and P and Q are transversal, and these are the intercept A, B, C, D, E, F. Okay. If these three lines are these three lines are parallel, these two are transversal, then the ratio of these two segment is equal to this two segment, that is AB upon BC is equal to DE upon EF. Okay, this is by the property of three parallel lines. Okay, so now this, on the basis of these four properties, we are going to solve a practice number 1.2. Okay, now let's see practice set 1.2. It's set, 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 not test. Now you have your textbook in front of you. Read the question 1. Identify in which figure ray PM is the bisector of angle PQR. Okay, so here in this sum we have to identify whether in which figure ray PM is a bisector of angle QPR. Okay, so if this is a bisector, then the ratio of these two segments should be equal to ratio of these two segments. Okay, so to check PM is a bisector or not, we have to find out the ratio of QM MR and QP RP. Okay, if these two ratios are equal, then we can say that PM is a bisector of QPR. So let's find out the ratio. So first QP upon PR. So we can also write PQ and PR. Okay, the length of QP is 7, length of PR is 3. There is no common figure between these two, so the ratio of QP to PR is just 7 upon 3, 1. Okay, now find the ratio of QM to MR. QM upon MR. Now length of QM is 3.5, length of MR is 1.5. okay, now remove this point. So 3.5, instead of 3.5 we can write 35 upon 10 and into, here in the denominator 1.5. Here also if we remove the decimal, the 10 is going on the numerator. Now 10 cancel, 5 3s are 15 and 5 7s are 35. The ratio of this two is 7 upon 3. So this is equation number 2. Okay, so from equation number 1 and 2 we get, so in triangle PQR, QP upon PR is equal to QM upon MR. The ratios, both the ratios are equal. Therefore we can say that PM is a bisector of angle QPR. Okay, so in such sum we have to find out the ratio of two ratio. If both the ratios are equal, here 7 upon 3 and here also 7 upon 3, if both the ratios are equal, then we can say that PM is a bisector of angle QPR. Let's see the second one. So once again, to find, we have to check that PM is bisector or not of angle QPR. Once again, find the ratio of RM to MQ. RM to MQ is equal to, RM is 6, MQ is 8. So here 3 2s are 6, 4 2s are 8. The ratio of this is 3 upon 4, equation number 1. And the another is RP to PQ, or we can say PR and PQ. The ratio of these two, RP, PR is 7 and here is 10. So there is no common factor. So this is equation number 2. So what will we get? What we get is both the ratios are not equal. So here you have to write RM upon MQ is not equal to PR upon PQ. Therefore ray PM is not a angle bisector of angle QPR. Okay, if both the ratios are equal, then this will be the bisector, and if both the ratios are not equal, then it is not a bisector. Let's see question number 3. Now this is M, point M. Here is the point M. Find out the ratio of QM to MR. QM to MR. QM is 3.6, MR is 4, is equal to 36 upon 4 into 10. Okay, now 4 9s are 36, 9 upon 10, equation number 1. Now second, QP to PR. QP, the length of QP is 9, PR is 10, equation number 2. Both the ratios are equal. Therefore in triangle PQR, QM from equation number 1 and 2, from 1 and 2, QM upon MR is equal to QP upon PR. Therefore, we can say that ray PM is a bisector of angle QPR. Okay. Now, question number 2. Just read the question in your textbook. Some data are given. State whether NM is parallel to RQ or not. Okay. So, to check whether these two lines are parallel, we have to check the ratio of these two. Okay. If ratio of PN to NR is equal to ratio of PM to MQ, then we can say these two are parallel by converse of BPT. Okay. So, we have to check these two ratios are equal or not. Okay. Now, so to check PN and NR is equal to PM and MQ, we need this length of all four segments. But here we have the length of bigger segment, that is PR, and smaller segment NR, but we don't have the length of PN. So first of all we have to find the length of PN, and here also we need to find the length of MQ. Okay, so these three are collinear point. Therefore PN plus NR is equal to PR. Okay, since they are collinear. Okay, length of PN we have to find, NR we have, that is 8 and this is 20. So PN is equal to, take 8 on right hand side, 20 minus 8 is 12. Okay, so length of PN is 12. Now find the length of MQ. Same way, PM plus MQ is equal to PQ, because all are collinear point. Length of PM is given 15, MQ we have to find, and the total length is 25. So MQ is, take 15 on right hand side, 25 minus 15 is equal to 10. I am writing direct. Okay, you have to go through the step by step. Then, so this is 10. Now check the ratios are equal or not. First ratio is PN to NR. PN to NR. Length of PN is 12, NR is 8. 4 3s are, 4 2s are, it's 3 upon 2. So this is your equation number 1. Then PM to MQ. So it's 15 upon 10. 5 3s are 15, 5 2s are 10. So once again 3 upon 2, equation number 2. So what will we get from equation number? From equation number 1 and 2. In triangle PQR, in triangle PQR, both the ratios are equal. PN upon NR is equal to PM upon MQ. Therefore NM is parallel to RQ. Why? It is by converse of BPT. So here we have to write by converse of BPT. Okay. Question number 3. Now the measurement, all measurement are given. We have to find the QP. This is what we have to find. What they have given, NQ. NQ is a bisector of angle M and P. Okay, so which theorem we have to apply here? Since they gave us a angle bisector, so we have to apply which theorem? Yes, angle bisector theorem. So here NQ is a bisector of angle M and P. Okay, therefore which two ratios are equal? Therefore MQ upon, start with Mn upon Np is equal to Mq upon Qp. Okay, now write all the measurement. Mn is 5, Np is 7, Mq is 2.5, and we have to find Qp. Okay, now here we have to write the name of the property which we use, that is angle bisector theorem. By angle bisector theorem. So every time we have to write the property which we use. There is a mark to write the property. Now cross multiply it. Qp into 5 is equal to 7 into 2.5. Qp is equal to 7 into 2.5 upon 5. If we remove this point, if we can also cancel directly. 5 5s are 25, it's 0.5, and Qp is equal to 7 5s are 35, so it's 3.5. Length of Qp is 3.5. Now question number 4. Now once again read the question carefully in the textbook. Measure of some angles in the figure are given. Prove that AP upon PB is equal to AQ upon QC. So this is what we have to prove. Now see, here they gave us these two angles are equal. Okay, now we have to check that we have to prove that these two ratios are equal. So now where is this? All four segments are there in the diagram. AP PB, AP and PB, AQ QC, AQ QC. Okay, so we have to prove the ratio of this two segment is equal to ratio of this two segment. When these two when these two ratios are equal, if these two lines are parallel. So we have to check whether these two lines are parallel or not, that is PQ is parallel to BC or not. Okay, now to check these two lines are parallel or not, we have to check the angles given. Now both the angles are of same measure, 60 60, and these are the angles, these angles are forming pair of corresponding angle. Okay, and we know that if the corresponding angles are equal, then those two lines are parallel. We already studied earlier. These are the two lines L and M, and P is transversal. If these two angles are equal, means a pair of corresponding angles are equal, then these two lines are parallel. Okay, so here angle P APQ and PBC both are of 60. That means they are equal and they are forming a pair of corresponding angles. So if corresponding angles are equal, then those two lines are parallel. So if these two lines are parallel, then by BPT these two ratios are also equal. Okay, so let's see how to write. Angle APQ is equal to angle PBC is equal to 60, that is given. Okay, but these two lines are, therefore we can write APQ is congruent to angle PBC. It's corresponding angle test. You have to write in a full form, corresponding angle test. Okay, sorry, here this is given only, this is given. So if these two angles are equal. Therefore PQ is parallel to BC. Here we have to write by corresponding angle test. Okay, if the corresponding angles are equal, then these two lines are parallel. So it is by corresponding angle test. Now in triangle ABC, PQ is parallel to BC. Therefore ratio of AP to PB is equal to AQ to QC. It is by BPT. Okay, hence proved. Now question number 5. Now in a trapezium. Now what is meant by trapezium? In a quadrilateral, if one pair of opposite sides are parallel, then it is called trapezium. So here they gave AB is parallel to DC, therefore it is a trapezium. Now what they have given, that all three lines are parallel, AB parallel to PQ parallel to DC. Okay, and some measurements are given. We have to find length of BQ. Now in the diagram we have three parallel lines. Then from the diagram we should know that which property should be applied. So we have three parallel line, so we have the property of three parallel line and transversal. Okay, so by the property of three parallel line and their transversal, so we have to write first line AB is parallel to PQ is parallel to DC. Therefore AP upon PD is equal to BQ upon QC by the property of three parallel line and their transversal. Okay, you can, if you want, you can write the property by the property of just three parallel line. Okay, now substitute the value of all. AP is 15, this is 12, this is what we have to find, and QC is 14. Now BQ into 12 is equal to 15 into 14. Therefore BQ is equal to 15 into 14 upon 12. So 3 4s are 3 5s are 2 2s are 7 2s are 5 7s are 35 upon 2. So BQ is equal to 35 upon 2 means 17.5. So length of BQ is 17.5. Now next is question number 6. Find QP. This is what we have to find using the information in the figure. Now see the diagram and identify which property should we use. We should use property of angle bisector theorem because the angle bisector is given. Okay, now use angle bisector theorem. So first of all you have to write that NQ is angle bisector of angle M and P. Therefore Mn upon Np, ratio of this two is equal to ratio of this two. Nq upon Qp, that is by property of angle bisector theorem. Okay, angle bisector. Now substitute the length of given segment. Mn is 25 upon 40. MQ is 14 upon QP we have to find. Once again cross multiply it. 25 into QP is equal to 14 into 40. So QP is equal to 14 into 40 upon 25. 5 5s are 25, 5 8s are, now 14 8s are, we have to 14 8s are 112 upon 5. Now divide 112 by 5, then we'll get it's around 22.4. okay, so length of QP is 22.4. Remaining few sums will be solved in next video.